Hello, we are the Data Dolphins. I'm Laher, and our project is Dermadex, which is essentially a skin disease classifier. Next slide, please. So we're going to start with talking a little bit about the project. Then we're going to go into some things we've learned under the data section. Then we're going to talk about some of the approaches that we use to train the model, and we're going to talk about our experience after that. Next slide, please. Then we're going to discuss a little bit about the results from the training, the implementation of the website. Then we're going to talk about the future scope and end with the conclusion. Slide, please. So let's go into that first point a little bit. The purpose of our model is to aid people or individuals to improve their well-being. We want to make this absolutely free because we believe in accessibility and affordability. We want everyone to be able to benefit from the positive impact of our product. Next slide, please. So now let's go a little bit into why dermatology the problem with dermatology as it is right now. So the thing with skin diseases is that early detection and classification are essential for the success of treatment. However, most of the tests that dermatologists perform are done with the naked eye. The problem with this is that this can result in unnecessary diagnostic errors. In fact, slide please. 13.7% is the overall diagnostic error rate of dermatologists. This isn't too bad, but it definitely has some room for improvement. Next slide, please. Our model, on the other hand, is a little bit better. It only has an error rate of 10%, which is, of course, better than the previous one. So now passing it on to Aiden to talk about the implementation.
Next slide. So hi, my name is Aiden, and this is our implementation of our model. So first, we collected all the data using RoboFlow. We annotated it in that same website. We also collected data using SERP API, and we used pre-processing steps in RoboFlow, like making the aspect ratio the same, that kind of stuff. And then we created a model with custom data sets that we collected, and it had a high accuracy rate. And we added the text generation model to the model in the website to add on to what the skin disease is that it identifies. And we use Flask and Inference API Hugging Face to deploy our main model on the website. Next slide, please. So this is just a summary. We use RoboFlow in the annotation, SERP API for image scraping, and Hugging Face for model implementation. Next slide. We use a Vision Transformers model, which is a free model offered by Google for the processing of images, and use Google Colab to train the model. And we use Replit to host the website interface.
Okay, so I believe this is me. So how the model works. So basically, the model takes in an image, puts it through the neural network, and it has different classes, and it determines what that class is. So you might see on YouTube, like sometimes they put like a video through, and then it shows boxes around the video. That isn't necessarily what's happening, or it's more just it's taking the whole image and only putting out what class the image is in. So in this image over here, in this case, it's a cat. And so then we also use vision transformers. So vision transformers, in our case, we're really able to help our model understand the important, basically image transformers. It takes the data and encodes it into numbers in an array, so like vectors, and then puts that through the model. And that was able to improve our model accuracy by a lot. So that definitely helped. And then we also implemented, this is one of our advanced features that we weren't sure if we were going to be able to implement, but we ended up being able to do it, which was text generation. And basically, we put in an incomplete sentence through a text generation model, and it gives us, it completes the sentence, and we kind of use that to trick the model into giving us an answer for any question that we ask it or something like that. And so then we hosted it on a website, and it was important that this website is easy to use. Anybody can just submit any image and then just get the results without any issue. So that was a big part as well. Next slide. Okay, so the model training. So we used a pre-trained model from Google, and we took that model and then trained it on our image data set. So in our data set, we had 11 different classes, 11 different skin diseases that we wanted to detect, detect accurately. And so we ended up collecting around 2,500 unique images of different skin diseases and labeled all of those. So actually one of the issues that we ran into in the beginning when we trained our model was some of the images that we collected using SERP API. And this basically goes online and just pulls tons of images from the internet. So we would type in like the skin diseases, for example, like I guess acne, not really a skin disease, but acne. You would just type it in, pull all the images that you'd get from like a search engine, and then label those. But one of the problems was that like some of the images were like kind of useless. Maybe they, Google maybe returned some wrong images, right? And we ended up marking those images as null, meaning there's nothing in the image. But when we exported our data set, the images were not marked as null, they were marked as acne. So our acne class was completely messed up, and the model couldn't really detect acne that well. So we ended up having to go back and either remove those images completely from the data set or just classify them correctly. So that was one of the issues we ran into that we were able to solve. So for our optimizer, we found that Adams it turned out to be the best for us. And for our training variables, I think the important thing was the epochs. And we actually found that if we went over 20 epochs, we overfitted our model. So it was, really good on the training data, but not really good on like any other data. And so that was kind of a big problem. So we kind of had to go back, and we actually found that around 5 epochs was the best number for us to around 5 epochs was the best number. And so the model in our case had its highest accuracy at around 4 epochs. So that's kind of what we went with there. Next slide. So our results. So this is our confusion matrix, and if you don't really understand, don't worry. Basically, the y-axis is the true label, so what the image actually is, and the x-axis is the predicted label. And basically what you want is a nice downward line, I guess like a y equals negative x or something. And so you can see here that we do kind of have that, and it does look pretty good for the most part. So our model, based on our test data set, had around a 90% accuracy, and we had a little over 150 test set images. So it looked pretty good. And then in the future, we probably would like even out our test set a little more, because some classes are overrepresented in our test set, if you can tell. So we would probably fix that in the future.
All right, so this is our Hugging Face interface. So what we did was we uploaded our model from Google into Hugging Face to show like how it works. In the first image, it scored a 97% accuracy, and in the second, it scored a 97. Similar with other ones from the test data set. So for our project, we used advanced text generation using an NLP model that was able to take half of the sentence and then continue adding on to it to tell us what sort of disease it was and how to cure it. For what we used a Flan T5 large, which would take half of the sentence, as said, and then add on to it over time. It stated the symptoms, the disease, and possible cures, and it just added on to the class. So for our future plans, we wanted to allow this to be able to be accessed by a lot of people in like rural areas, very taken away from society, like disconnected. So it can be used and helpful in places without as much medical attention. And then we have a video. Let me know if you can hear it.
Doesn't seem like we can hear it.
I don't think I
Okay.
can hear it.
Okay. Now?
I still don't think we can hear it, Carter.
I think you need to stop sharing and then You have
quick
to
screen
share
share.
sound. It's a small like button at the bottom of the thing.
I can hear it.
Okay. It's kind of quiet at the start.
Carter, maybe post that video in the chat. That way people
Yep.
can watch it on their own.
Okay. And then
Okay, so our conclusions from the model is that this model is meant to improve the lives of many and provide a cheaper method of skincare. We want to implement this model worldwide and give everyone a better product. Next slide. So thanks for watching and having us here for our presentation. And this presentation template was created by Credits. Also
and
check us
for-
out on the Dermadex website. Someone will post in the chat.
And then for an example of it working, for the test data set, it scored 97% on warts, which is correct. And for this, it scored 95.6. So it's pretty accurate.